Today I would like to introduce you to the nomenclature of alkyl halides. When naming alkyl halides, the simple halides can be named by one of two methods. They can either be named as their functional group is named, or they can be named as a substituted alkane. For the functional class name, it's named as an alkyl halide, so the molecule in the middle of the screen would be named as methyl bromide. For the substituted name, it's named as a haloalkane, so the molecule on the screen would be named bromomethane. The substituted alkane is the preferred IUPAC nomenclature method. IUPAC stands for International Union of Pure and Applied Chemistry, and those are the folks that come up with the nomenclature rules. When using the substitutive or systematic method, the halides are always named as prefixes, and the prefixes are fluoro, chloro, bromo, and iodo. The alkyl halides are named in a manner that is very similar to naming the alkanes, so the same rules apply when numbering the alkane chain and alphabetizing the substituents. Let's walk through a few examples. For the first compound, I would number it right to left so that the bromine has the lowest possible number. This would be 2-bromobutane. For the molecule on the right, I would number it right to left so that the first substituent has the lowest possible number of 1. And I see that I have a dibromo and I have a chloro, and the root is a pentane. I alphabetize by the B of the dibromo. So this would be 1,2 dibromo, 2-chloro, pentane. For the last example on the page, I have to find the longest continuous carbon chain, and I actually have two. This is a hexane, and this is a hexane. You would want to have the most substituents possible, so this is going to be the carbon chain that we use for our nomenclature. When numbering the chain, I see that parts of my name are going to be 2-bromo, 2-fluoro, 3-ethyl, 4-iodo, and hexane. And I put all that in alphabetical order. 2-bromo, 3-ethyl, 2-fluoro, 1-iodo, hexane. For the examples on this page, it's not particularly obvious which way the compound should be numbered. For the first example, for instance, I could have a 1-methyl, 2-bromo, or I could have a 1-bromo, 2-methyl. In such cases, you number it so that the priority is given to the substituent that comes first in the alphabet. So this would be named as 1-bromo, 2-methyl cyclohexane. Remember, we don't have any spaces in the word. For the next compound, it doesn't matter whether I number it left to right or right to left. I have substituents on carbons 2, 3, 4, and 5. The bromo is going to have the priority by alphabetical order, and so I give it the lowest possible number. That means this compound is numbered left to right. Then when I alphabetize, I would have 3-bromo, 5-chloro, 2,4-dimethyl. Remember, that's alphabetized by the M, hexane. When thinking about the reactivity of alkyl halides, it's important to know how to classify them based on their structure. For instance, if the carbon bonded to the halogen is not bonded to any other carbons, it is going to be a methyl halide. If the carbon bonded to the halogen is bonded to one other carbon, it's going to be referred to as a primary alkyl halide. And primary is often written as if it were 1 degree, but we refer to that as primary. A secondary alkyl halide is one in which the carbon bonded to the alkyl halide is bonded to two other carbons. So this is going to be secondary. And the last example is a tertiary alkyl halide The carbon bound to the halogen is bound to three other carbons, three methyl groups in this case. That is a tertiary alkyl halide, and it's the T-butyl chloride that's shown in the upper left-hand corner of this slide. You may also see the terminology of geminal dihalides or gem dihalides. Those refer to alkyl halides in which there are two halogens on the same carbon. And you may see vicinal dihalides. Vicinal dihalides are compounds in which you have a halide on neighboring carbons. Some other tidbits regarding nomenclature. If you have a structure of CH2X2, you have a methylene halide. The CH2 group is a methylene group. So if you had chlorine as your halogen, you would have methylene chloride. It is a common solvent in the organic lab. If you have CHX3, it's a haloform. Chloroform is shown on the screen. Chloroform is also a common solvent in the organic lab, and deuterated chloroform, CdCl3, is a common solvent for NMR spectroscopy. Carbon tetrahalide, like carbon tetrachloride, is the CX4 molecule. So in summary, the simple alkyl halides can be named by a functional group name. In other words, they are alkyl halides like ethyl bromide. But the systematic nomenclature in which it's named as a substituted alkane like bromoethane is preferred. When you're using the substitutive or systematic method, the halides are always named as prefixes. You number alkyl halides by the same rules that you use with the alkanes, so you'll number in a manner that puts the first substituent with the lowest possible number, and then when you're stringing them all together, you do so alphabetically. It's important when thinking about the reactivity of alkyl halides to recognize whether you are using methyl, primary, secondary, or tertiary alkyl halides. And occasionally you'll run across terms such as a geminal or vicinal dihalide, or something like methylene chloride, chloroform, or carbon tetrachloride. I used two organic chemistry textbooks as I prepared this lecture.